Hello everyone, I'm honored to attend this conference. Um, this conference is EAI Cloud Computing International Conference. I'm very glad to there to presentation my research contents. I'm one author of the paper, a privacy-aware computer offloading method for VR applications. Today I will presentation my research work. Uh, Firstly, let me introduce myself. My name is Peichen. Uh, I am the one of the authors of this um, paper. I come from Huaqiao University. Let me show your my research. In this part, I will to talk about our research contents. As the new technology, VR is constantly enrich the people's experiment. VR has bring the mobile users immersive experiments because of based off these technologies. Um, VR applications has high requirements of the performance VR device, but the computing resources of VR device are limited and horizontal. Mobile edge computing provides an effective solutions to solve these operative issues by offloading the VR application to edge servers or edge nodes for purchasing. Nevertheless, the research of edge servers are limited and homogeneous, and thus it is necessary to consider the load balancing of edge servers and the mentioned photon latency of the VR device, also the energy consumption of AR device. VR device. In addition, because of the VR device will to collect the some users' information from VR sensors. User privacy protected in the purchase of computer offloading is very important issues, and it need to take into the consideration. In view of this, in this paper, we investigate the computer offloading of VR application with privacy preserving. Technically, we propose a privacy-aware computer offloading method based on a multi-objective genetic algorithm to obtain the optimal strategy for VR application. Finally, it is shown that the proposed method is effective through extensive experiments. The main contribution of this paper can summarize as 3 points. Firstly, we model the computer offloading problem as a multi-objective optimization issues, where the mentioned photon latency and energy consumption of VR device, as well as the load balancing of edge servers, are considered as optimization objectives, and the privacy preserving is considered as a contrast. Secondly, computer offloading method for VR applications based on multi-objective optimization genetic algorithm named MCO VR is proposed to address the brave issues. We conduct a large number of comparative experiments to provide to prove that MCOVR can obtain the optimal computer offloading strategy for VR applications. The system model can are shown as the figure. The MEC enabled VR applications. In this figure, we can see the VR device and VR users are. We can see the VR device is obtained by VR users and is connected with edge servers by one local area network (LAN), and because of the edge servers is nearly to VR users of compare with the cloud center. The cloud center is all usually has genetic uh, distance, long genetic distance with the VR user or edge servers. They connect the cloud center via one area network. When users offload the edge servers can has a higher transmission rate and offload to the cloud center has lower offload transmission rate. In this presentation, we will show the fluent chart of the MCOVR. As shown in figure of fluent chart of an MCOVR, we can see the argument designs, the all fluent of this algorithm. Firstly, to the start of the algorithm, MCOVR, we will firstly initiative the populations, and the population evaluated in two steps, and through the evolution, we will obtain the reference points, the ideal points, and the bad points. Then execute the RR ranking. RR ranking will spread the population. It's just like the Pareto selection. Then the argument will see the international numbers is achieve the maximum internation or not. If not, the estimate will execute again, and finally, when the maximum internet is achieved, output the optimal computer offloading strategies. This part we will to presentation the latency and the energy consumption and load balancing of the MCOVR. The experiment is very important for this MCOVR methods. Firstly is latency. Latency means magnetophoton photon latency. In these figures, we can see the result of magnetophoton photon latency between three methods. The three method is the benchmark. Benchmark is the firstly is benchmark. Benchmark is the random select of computer offloading strategies. They will to random select the edge server or the local device or the cloud center to offload to execute the offloading method. The first and secondly is first come first serve method. The first come first serve method is is the FCFS. The FCFS the task will to orderly to execute the by local device or to orderly to offload to edge servers. And secondly is our proposed method MCOVR. In the figure A and B and C, we can see the MCOVR can achieve the optimal result of between among three methods. In the figure A, we can see that when the number of VR devices is increasing with one application and 5 nodes and 6 edge servers, we can see our method can achieve the best result of among three methods. Because of the benchmark is random method. We can't this method is count to predict very exactly. So this under the first come first serve, this method is very not great and it is and these two method is not good with our proposed method. In the second focal figure, it is the result of energy consumption. Energy consumption includes three parts. The first is number of VR device. The secondly is number of application. Finally is number of nodes. In the figure A, we can see our proposed method and is the best one, and the figure B is also, and figure C is similar to figure A and figure B. Because of the energy consumption has high related with marginal photo latency. So if marginal photo latency is lower in three methods, the energy consumption is also lower between among three methods. So we can say MCOVR can achieve the best offloading strategy of in energy consumption. Finally is the load balancing. Load balancing means the load balancer of among three methods. A load balancer is has high related to a scarcity of edge servers because of the one the edge server is not balancing the load balancer load balancing value is too high. The load balancing is calculated by the average research unity and one of research unity. We to we can find the gap between two values and calculate all of the edge servers gap. We can to obtain the final load balancing as the optimal objective. In this figure, the figure of result of load balancing, we can clearly reflect because of the benchmark is not predict is random optimum. So the load balancing of benchmark is not good, and the first come first serve because of this first come first serve is too orderly. So the load balancing of this FCFS is not good yet because of the edge servers are homogeneous. They have different computation results. Finally, we can see our proposed method is very can achieve the good result of among three methods. Finally, we can conclusion of these papers. We start the problem of multi-objective computer offloading VR applications. Correspondingly, we propose the method named MCO-VR to memory-less magnitude photon latency and energy consumption of VR device and the load balancing of V8 servers genetically. We also consider the privacy conflicts in VR application and using the privacy placement model to protect the user data information security. Finally, the experiment results have shown that our proposed method is effective. In the future work, we will start the mobility object aware computer offloading for VR application. It is the augmented reality application in smart cities. And the thanks for listening. Any questions?